Hello guys, welcome back to my channel. So in today's tutorial we're going to talk about the race condition. So in the last tutorial we talked about multi-threading and what multi-threading is, and we see how we can write a multi-threaded program in Python. But one disadvantage of multi-threading is that the race condition. So what's the race condition? So it can be really confusing to understand a race condition. So I'm just defining what a race condition is for you. This I got it from a website online called pythontutorial.com. So I'm just going to quote what they've defined a race condition as. So a race condition, they said, a race condition occurs when two threads try to access a shared variable simultaneously. So when you have two threads that are trying to access a given variable simultaneously, then that's a race condition. So for example, let's say that I'm trying to add up two numbers, right? I have a variable, a global variable named 0, right? Is initialized to 0. And then I'm having a multi-threaded program with two threads. So I'm trying to the first thread is going to add 30 to the number, and the second thread is going to add maybe 70 to the number, to that 0. Okay, so all of them are going to read the value of that variable. So all the two threads will have that variable being 0 0, right? And then the first variable will write 30 to it, and the second variable will need to write 70 to it simultaneously. Now, which at the end of the day, what result do I get? Do I get 30, 70, or 100? So that's a race condition. So when both threads try to change the value of the shared variable, and they race to see which thread writes the value the last, because the thread that writes the value the last is the thread that wins the race, kind of, you can think of it like that. So if the one of 30 writes first, then 70 will come to override it. So from 30 to change to 70, so the result we get finally will be 70. If the 71 writes first, then 30 will come, the 30 thread will come to override it, and then the final result will be 30 rather than 70. So this is a race condition. It's really difficult that you achieve 70, because 70 will never be achieved, right? So this is a race condition, and to demonstrate this to you, I'm going to write a simple program, and then we'll talk about how it works. In that way you guys can understand even much better. So I'm going to close this up, and then I'm going to create another variable in here, and I'm going to call it race underscore condition.py. So inside the race condition.py, we're going to simply write a program that simulates a race condition. So I'm going to import this. I'm going to say from trading import thread, just like that. I'm going to say from I'm going to say import time as well. Let me just leave the timeout. We don't really need that, so let me just leave the timeout, and I'm going to create a function def increment underscore counter, and this is going to take in a variable to increment the counter with. So I'm going to create a global counter. So this global counter by default is 0, so I'm going to say global underscore counter and then 0. So in here, I'm going to refer the global counter. So I'm going to call it global underscore counter, just like that. I'm referring the global counter in my local function scope. So I'm going to local underscore counter, and the local counter is going to be the global counter. Okay, and I'm going to do local counter underscore counter, and I'm going to add I'm going to say plus equals to, let me just say plus typing the wrong key, plus equals to x. You're going to get whatever value you're going to get, you're going to assign it to the local counter, which points to the global counter. And then I'm going to now wait for a bit of time. So I'm going to time to sleep. I'm going to sleep for let's say 0.1 or 0.1 second, and then I'm going to okay, let me just close this. I also need to import time, so I'm going to go ahead and import time. Okay, let me just remove this global import and if I need it. So now that we have that, I'm going to do global underscore counter is going to be equals the local counter. So in here you're referring to the global counter. You're referring to the global counter. You're going to create a local variable that reads the global counter, and then you're going to increment the local variable, and then wait for some time, and then assign the result back the global variable in here. Okay, and this is going to be done by each thread whenever I calling this function. So let's go ahead and actually write an entry point if name equals to underscore main underscore what you're simply going to do in here, you're going to say, you're going to create a thread. I'm going to call it T1, and T1 is going to be I'm going to create a thread here, and this thread is going to have a target or which function to run. So I'm going to say incremented counter. That's the function is going to run. You're going to pass in an argument. I'm going to pass in an argument as a tuple, and I'm going to simply pass in 20 initially. I'm going to create another thread called thread2, and it's going to be thread2 is going to be thread, and then let's have a target for this thread. So it's going to call the increment counter, and then the argument is going to have, we're going to pass in, let's say 70. Okay, just like that. So now that I've done that, I'm going to go ahead and actually start my thread. So this is how you create threads originally in Python before the thread pool executor came along. So I'm going to t1.start. I'm going to start that. I'm going to start thread2.start, and then I'm going to go ahead and join this thread. So t1.join, just like that, and then I'm going to do t2.join, just like that. And I'm simply going to go ahead and actually at the end of the time I'm going to print global counter here. So let me fix this indentation error. So I'm just going to grab all of this, and then yeah, so that's basically what I'm going to do. So here I've created a thread, two threads. One is going to pass in 20 as an argument, and one is going to pass 70 as an argument. I have started the threads, and I'm going to wait for these threads to complete their process by using the join, and then at the end of the day I'm going to print the value of thread. Okay, so let me ask you, before you run this program, just take a minute and think what the output will be. Okay, will the output be 90? Will the output be 70? Will the output be 20? That's just take a bit of time and then think about it before running the program. So I'm going to go ahead and actually clear the terminal and run this program right now. So let me just lowercase, so it'll be Python 3, and then it's called raise condition. So just run that. The output is 70. Let me run it again. It's 70 again, 70, 70. Sometimes if you run it, you might get 20. So you have to run this a couple of times to get 20. You might get 20 just. You can see most of the time you're getting 70. Let me just try to change the time a bit here. So sometimes you might get 20, but I don't want to spend all the time running this to get 20. Most of the time you're getting, okay, now we get 20. So you can see the output is, and this is what the raise condition is, because these two threads are trying to raise to see which one will override the savings of the other, because initially maybe 70 got saved first and then 20 came to override it, and here we got 20 as the final result, and then the second time 20 reached the finish first, and the value of global was 20, and then 70 came along and keep the global value to be 70. It means it override what this thread one has done. So this is what a raise condition is in Python. So and other programming languages raise condition also apply. So how do we make sure that we fix this raise condition? So let me just create another file here. I'm just going to call it raise underscore condition solution.py. Okay, so I'm just going to go ahead, copy everything in here, copy it, and then paste it in here. So once I have done that, what I'm simply going to do, I'm going to make this to be what we call thread safe. So to make this to be thread safe, I'm going to use something known as a lock. So a lock is going to make sure that whenever a certain thread is working with this variable, another thread will not be able to read the variable. So this thread will come along, read the variable, this value to be 0, and this thread will come along and read the value to be 0. So what you're trying to prevent is that whenever this thread has read this value, this variable here, and is working with it, then this thread should not be able to also be able to read that value. So we're going to use a lock to achieve that. So what I'm simply going to do is I'm going to now create a lock. So to create a lock, we just come down here, and I'm going to create a lock here. So I'm going to say from trading, I can go and actually import colon lock, just like that, and I can come here and create a lock. So I'm going to do the lock. A lock is going to be lock, just like that. Create a lock object, and this lock object I'm going to also pass it into my functions here. So I'm going to pass it in here. I'm going to say lock, just like that, and I'm going to also pass it in here. I'm going to say lock, just like that. So in here we should expect also lock, so I'm going to pass in lock, just like this. And what we have, lock has mainly two main functions that you want to use, two main attributes. So the first one is the acquire. So the acquire means we are going to acquire the lock, means that other process cannot execute whenever we have access to the variable. Okay, it means that you're going to lock the function, okay, to prevent any race conditions. So if I'm working with this function, then other threads will not be able to work with this function, work with all the variables. So I'm going to acquire the lock, so I'm going to say acquire. They're going to call the acquire method, and at the end of the day, once we're done updating the variable, we can call lock.release. okay, we're going to release the lock so that other threads can go ahead and use that function, okay, or to be able to execute this part of the code of this function. So now that we have done that, if we run this program again, let's see what we get. We get 70. Okay, I actually need to say Python. I actually ran the wrong file. This is race condition underscore solution, and then we run this again, we get 90. And every time you write, we get 90. And this is how our program, we are expecting our program to perform, right? Because 70 plus 20 is 90. So we are going to using the lock whenever a certain lock is working with this function, other locks cannot also work with this function. Hence, we prevent this race condition. We tell it, wait first, when this lock is done, then you'll be able to have access to it. So we start T1, and when T1 is working with this, we tell T2 to wait until T1 is done, and then we release the lock, and then T2 is will be able to execute its process. So in this case, we'll always be able to get the right output, the expected output, in this case 90, without having this race condition. So if you can even multiple times, you always get 90 as expected. So that's what the race condition is all about. Yeah, I've seen an example of race condition and how to prevent a race condition using a lock. So that's all for this tutorial. So if you guys would like it, give it a thumbs up and subscribe to my YouTube channel for more videos like this. Thanks for watching. See you in the next one.